Hi again, everybody. This is a tutorial. What happens if there's a short and an open? And this is a complicated subject. There are very different situations that arise. Now, this is an automotive schematic, as you see, and this is a basic, almost like the stage, the block diagram of it, not the component. And as you can see, each stage, each component, starter, generator, has its purpose, obviously, and then current is fed through this. But before we understand this, if there's a short here or an open, I have to first explain the simple analysis of parallel circuits and series circuits, and hopefully that will give you a better grasp of what I'm trying to accomplish here in this video. And please subscribe to my channels. My channel is Joe Electronics Schematics, which is schematics, and my other one is Automotive Electronic Schematics by Joseph. Let's begin by the basic electronics and try to analyze. Two circuits over here, parallel, series. So I just put in my own units of measurements over here, and the resistors, the ohm values for the components. Doesn't really matter what the values are. The concept is, let's say we have a short. Okay, now, parallel circuits, if you look, the voltage is the same from here to here, from here to here, from here to here. 12 volts across here, 12 volts across here, 12 volts across here. Why? Because it's the same point. So the voltage has to be the same across here, and across here. We look at this one. They're trying to confuse you over here by changing the wiring diagram of it, but it's the same. So as you see over here, this is in parallel, and this is in parallel. These are across each other, and across this power supply. Let's say this is a car battery, which I'm trying to explain and analyze to the viewers. So a 12 volt automotive car battery, and let's say I have a load. Let's say I have a module over here, a PCM module, and a BCM over here, or airbag module, TCM module, whatever it is, doesn't matter. So we know parallel circuits, the total current comes here, through here. The total current flows, and that's why I always teach current. If you understand current, you'll understand what happens to the fuses and the components. If you learn voltages like many mechanics, it will not help. So go over here, and the total current goes here. Now it has two nodes, two branches. It's called a node and a branch. Two branches of equal value. So let's say we have 2 amps. 1 amp will go here, 1 amp will go here. This is series. The total current is the same throughout the whole thing. If you have 6 amps here, 6 amps here, 6 amps here. Because why? You have no branches for the current to split up. Same concept over here. Same total current through the whole thing. Now, let's take, we have a short across here. Let's say this wire is touching this wire, or this component, this resistor, is actually shorted itself, 0 ohms. There's a difference of a short and a dead short to ground. Dead short would be, I have 0 ohms from here to ground. Basically, the car battery shorted out. It's like me taking a jumper and placing it from positive to negative. This is what I'm doing right now. So I put a fuse over here. If this is shorted, where will all the current go? That's the first question you ask yourself. We know that the current takes the path of least amount resistance. Well, you can't get less than 0 ohms. So therefore, all the current, instead of flowing here and splitting up, it sees this and say, oh, this is a great path for me to go. I have low resistance. Bang, I'll go right through here. Therefore, if there would be a fuse here, the fuse will blow. Let's say I put a jumper over here. This one now is shorted out. This one is shorted, and this one is not shorted. Same scenario. What would happen? This is 0 ohms. The current will flow right to this one. It will avoid these because this is the path of least amount of current. So if I have a fuse over here, it will blow. If I have a fuse over here, not blow, it blow over here. If I have a fuse over here denoted by this, or signified by this, this will blow. This fuse will blow. This fuse is for the total current. This fuse is for the individual current. And this is what I'm trying to get across, as you're going to see the schematic for the automotive. So let's go to the next one. I have a short across here. What will happen? There's a dead short to ground, because this is going back to the negative. What will happen? 0 ohms. Where will all the current go? Again, right through here. So let's have a purple wire over here and I have a white wire. They're being touched over here. The current goes over here, says there's resistance here, there's resistance here. Oh, all the current will flow here and blow the fuse. Let's take it a step further over here. Same scenario. I have a short across here. Let's say this wire is touching this wire in automotive. Let's say this is a MAP sensor. This is a mass airflow sensor. There's a 5-volt source. There's a 12-volt source is touching the ground, let's say, on a MAP sensor or mass airflow sensor or TPS sensor, whatever it is. Let's say 2 wires in the connector internally are touching each other. Therefore, look at the current. The current will say, okay, I want the path of least amount of resistance. This is 0 ohms. Boom, I'll go right here. We will blow the fuse, yes. Whether I put the fuse here, whether I put the fuse over here, doesn't make a difference. It'll still blow the fuse if I put it over here. Why? Because all the current will go here, not here. Let's take this scenario, a series circuit. I jumped out this. Again, could be a MAP sensor, mass airflow sensor, coolant temperature sensor. The connector itself could be shorted. One terminal touching the other terminal, doesn't matter. This is the short. Remember, we discussed a short to ground. That's a dead short to ground. Is this a dead short to ground? It's a short, but it's not a dead short to ground. Why? Let's analyze. I have 0 ohms here. The value of each resistor is 1 kilo ohm. This is 1 kilo ohm. So if this is shorted from here to here, again, let's say this is a MAP sensor. This is an oxygen sensor, the connector. Let's say the purple wire is touching the white wire. I have 0 ohms across here. Yes, I do. But one second, we have a series circuit, so therefore we're still limited by the 1 kilo ohm resistance of this one. So it's not a dead short to ground. We still have 1K in this circuit to limit the current. So the current will go higher, right? It will go higher. The question is, the rating of the fuse, is it enough to go higher to blow the fuse? That's the question we have to ask. We have to keep in mind that the jumper over here shorts out this resistor. However, we still have 12 volts looking at 1K from here back to ground. Let's take the last scenario, and this is what I'm trying to get to in automotive. The jumper goes from here, if I could draw it, from here to ground. And ground goes obviously to here. Now, what did we do? Guess what? We jumped out. We have a dead short to ground. If I will measure the ohms, I will measure 0 ohms from here to here. Now, this is different from the scenario I just told you before, because now we have no limiting resistance. This is shorting out or bypassing 2 resistors. So therefore, this is 0, this is a dead short to ground. The fuse has to blow. Let's take this one. Again, look at this one. I shorted out this one. Is this a dead short to ground? It's a short, right? Current will bypass this. However, you have to think this will still be limited by this resistance, and this resistance. Is it enough to blow the fuse? depending on the rating of the fuse, depending on how much current, is still being limited by only these 3 value resistors. Now, let's go further. Here's a short to ground, right? Again, guess what happens now? Now it's like I put a jumper across the battery, if you can see that. Therefore, this is shorted out, this is shorted out, this is shorted out, this is shorted out. A dead short to ground. There's a difference between a parasitic load, a parasitic draw, being loaded down. All these terms are used a lot, but we have to understand parasitic load is when the battery, when the engine is off, and you're not cranking or anything, but let's say the headlights are on, or a theft deterrent system is on, or something is on. You're drawing current, but you're drawing too much current. You don't want more than a 1 amp current when the car is off. So therefore, this is a dead short to ground. It will blow the fuse? Absolutely, it will blow the fuse. We hope it blows the fuse, right? So those are the fundamentals of circuits, and I hope you understand that. If not, try to go over it. Going back to this is why I said what I said. Try to analyze. As you can see, stage diagram of the loads. As you can see over here, obviously the car battery, obviously, with multi-cells in it to make 12 volts, goes to the starter. The generator, after it's cranked, the belt, turning the pulleys and all that, will produce obviously maybe 14 volts and recharge the battery and keep the accessories going. Because now the battery is weak, it's drained out. So, let's look at where the fuses are. Series circuits, parallel circuits. Still the fundamentals stay the same. Okay, now first when we turn it on, obviously the battery is doing all the work. Right? Engine is turning, the crankshaft is turning, the camshaft is turning, the pulleys are turning, the generator is turning, the AC, which transforms it to DC. Because we need DC to recharge the battery and to keep the accessories going, which are B plus DC. So, anyway, look where the fuses are. The common fuse is over here. This is the fuse. All the current has to flow through this. This is secondary air injections pump. You have it in Chevys where you almost recycle the air back into the cylinder again for combustion, better combustion. The point is, if you have a short to ground or you blew one of these fuses, I had a short to ground, right? I blew this fuse over here. What will be affected? Well, if this is blown from too much current, this fuse will still have current going through it, through the pump. This fuse is blown, we're going through the ignition switch in this position. Therefore, if you look at it right here, see, ignition fuse, these will be affected. All this will be affected. Fuel injectors and a fuel injection system called central sequential fuel injection. Ignition control module, ignition coil, power control module. Individually, these are the fuel injectors. We will open the fuel injectors to allow fuel into each cylinder. Obviously, this is 6 cylinders. These will be affected because now this fuse has opened. Ignition, no spark. We need B plus. We need B plus, B plus, B plus, B plus, B plus, B 12 volts to each one. Powertrain control module. Well, guess what grounds the fuel injectors? The computer turns on the car. Also gives a control sometimes to the starter. and fuel pump to the fuel pump. So everything will be affected. Why? Because this one blew. Where do we have the short? Could be over here. Could be over here. Could be the modules. But what's being affected? All of this. This is the engine. I call it for the engine performance. Spark, fuel. This creates the spark. This gives it the spark for the timing. And I made many videos about this. I made many videos about this, how this is responsible for this. This has to give to ground the transistor. This has to ground the fuel injectors for it to work. No, if this doesn't work, forget about this. So therefore, if this is open, this will be affected. If this is open, guess what else is affected? Instrument panel cluster. That means the instrument cluster will not be lit. The body control module, which is also in charge of accessories, as I said, that I made the videos about. Airbag system will be affected because this is in charge of all of this. Last one, if the fuse is intact over here, there was a short, but the fuse is good over here, and the fuse blew over here. Why? Because one of these is shorted. The connector over here is shorted. What would I do? I could lift up the connector, lift up this connector, lift up this connector, or try to lift up whatever connectors that I have. The old-fashioned way is also to take out the fuses, obviously. You can measure the voltage drop across. I like to put a current meter through it. But anyway, if this one is blown, this will be affected. You're not going to crank. However, body control module, instrument panel cluster can be lit, depending where. This is why I say pay attention where the fuses are and get a schematic. Depending where the short is. I have a short from here to ground. What will happen? Will it blow this? If I have a short from here to ground, zero ohms. This is like a parallel circuit, right? So the current will flow here, not here, and not here. Is it enough to blow? Well, I have no resistance, so therefore it would blow the fuse. What about a short over here? Will it blow the fuse? Yes. So anyway, I'm going to make another video about this also in more detail. So please subscribe to my channel. Again, keep in mind it depends where the fuse is. A common fuse, where the short is. And this is part 1 of the videos that I have a lot about making a short, finding shorts. So please subscribe to my channel. 2 channels, Joe Electronics Schematics, please, and Automotive Electronics Schematics by Joseph. And like I said, I have videos over there about scanner, what the definitions are. Not available nowhere on YouTube. Thanks for watching.